Hello and welcome. This is Magri Abrar Hassan. The objective of our presentation entitled IOT-based LPG leakage detection system with prevention compensation is to provide security in home automation. This is the table of contents comprising chapters that we are going to discuss. Moving to the introduction part. As most of you know, LPG stands for liquefied petroleum gas, and it's seeking its sole importance for use in industrial, agricultural, commercial, and manufacturing applications. There is a drastic increase in the demand of LPG gas due to its eco-friendly nature, as energy sourced from it is pollution-free and is being derived from fossil fuels, and also it has an ease in its installation process. That is the reason for its wide-ranged market. The second point is it is a colorless gas, and its composition includes 60% of the butane and 40% of the propane, which are highly flammable gases. Also, the LP gas cylinder is designed to withstand a pressure of up to 25 kgs per square centimeter. That is like a 25 kg weight put on an area of your fingernail, and obviously that is a massive pressure to control, and it is a serious matter. Occasionally people indulge in unsafe practice in storing of a gas tank, like throwing it, which may damage the welding or body of a cylinder, or sometimes we place the cylinder close to the heating appliances, which may raise its temperature and pressure inside, and once it goes beyond the maximum limit, the metal of the cylinder may fracture and may explode. The LP gas ignites when it forms between 2% and 10% of vapor by air mixture. So the risks involved with poor handling, storage, or usage are great. And in case there is a leakage, we just need a tiny spark or some surrounding source of ignition to complete the fire triangle. For example, an already ignited fire started some distance can very quickly travel towards the source of a leak in itself, resulting in explosion of the cylinder. And apart from being colorless, LPG is an odorless gas. And to make it odorant, we proceed by manual addition of ethyl mercaptan, which is a clear liquid with strong smell, and we add it so that LPG can be sensed. During inhalation, it may lead to suffocation, but in case there is the absence of any human resource at the spot to who may have perceived the smelling signals, or there is someone but with feeble sense of smell, then it becomes unaffordable to rely on this intrinsic safety mechanism, and we may experience terrible fire eruptions and devastating explosions due to rupturing of gas cylinders. So yeah, it's evident, despite LPG being a strong fuel source which can even empower cogeneration plants, but at the same time it's one of the common reasons for fire breakouts and causing terrible accidents, particularly in closed buildings. So we can say that LPG is a threat, but at the same time it is the need. And the evidence is a brief list that I'm going to present, where date and spot of accident is mentioned. For example, on 30th of November 2019, a woman along with her 3 daughters and 3 others got killed when an LPG gas cylinder caught fire at their home. Similarly, on April 27, 2018, a mother-son duo, whose photograph will be shown in next slide, got injured due to LPG blast and succumbed to their injuries in the hospital. And similarly, it goes on. Since I have compiled a brief list of these mishaps, and this list would go on if we will be talking about worldwide situations. These are some images of bursted LPG cylinders which literally have turned into explosive devices. And on the right side is the image of a boy, Raj Yadav, who along with his mother succumbed to their injuries in the very evening of the incident. So, to work for the provision of some specific safety apparatus which can avoid these many threats becomes the need of the hour, and such are the objectives of our project. Moving ahead, the objectives, the first one is proactive safety system with real-time response. The implementation of a safety system in public places, households, offices, industries, etc., who tend to use LPG so that it can accurately detect the emergency situation and provide real-time response. And how we are going to do it? We are going to design an IOT-based microcontroller system. Since you know IoT stands for Internet of Things, and there's an endless amount of data everywhere and all around us. And what IoT does is to establish a seamless connection between the physical world that includes assets, capital firms, financial services, data analytics, gadgets, and of course people, and the digital world. So, in short, IoT established a connection between the physical world and the digital world by the data, and this data, when collected and streamed together by coordinating several systems and gadgets online, can be used for a variety of purposes that are beneficial for higher and better living conditions. Our third objective is detection, alerting, and automation. That is, equipping people with an economical and effective alarming system which not only can detect the severe threat but would alert and also can automatically control it by its safety line of action. Such system apparatus would be reliable and easy to install and smooth in operation. And to cut the long story short, our aim is to replace that threat associated with the LPG in its safety, and we want to elaborate a safe medium for its usage. Moving ahead, this is the block diagram where different electronic components are connected with Arduino. Talking about the Arduino is an open source programmable circuit board which contains microcontroller that can be programmed to sense and control a wide variety of objects in the physical world. And here, by means of jumper wires, we have added other components with Arduino like MQ6 gas sensor, which can detect the presence of gases like LPG and butane, and the ability of this gas sensor to detect these gases depend upon the chemiregister, which generally is silicon dioxide and is placed on its nozzle part. As soon as the sensor is placed in some toxic or combustible gases environment, its interface reacts, resulting in the conduction of current, and that current we are using for switching purposes. After it, we are using a piezo buzzer, a buzzer which is integrated with Arduino, and its operational function is being programmed as well. Then we have added ESP8266, the Wi-Fi module, which is connected with the electronic gadget that may be either a computer or a mobile phone or a tablet to enable us the displaying medium of working of the project. And also there is no need of internet facility for its working. Also, we have used some LEDs of different colors, for example red and green, whose fast response rate or switching times helps us in maintaining the decorum of the project. And at last, we have used a servo motor connected, which in itself is an electrical device that can push or rotate an object with a greater precision and angle by its valve. Since this rotation is being programmed, and here we use it for switching gas supply on and off. Talking about the hardware implementation, this is the sequenced connection that you can see onto the display. And on the interface of Arduino, we connect MQ6 gas sensor first with 5-volt pin and other with ground terminal of the Arduino board, and its output as per program is being taken at digital pin 3 of Arduino board, and you can select any digital pin you like in your program, but I'm talking about the program that I have compiled here, and I'll be putting that program in the description. Then we have used ESP8266 Wi-Fi module and integrate it with the Arduino board. It's connected with 3.3 volt pin and ground pin. The transmitter pin of Wi-Fi module as per program is connected with 10th pin of the board, and the receiver pin of the Wi-Fi module is connected with the 11th pin of the board. Then after that, I have kept the connection of buzzer and LED same. That is anode with pin 12 and other terminal is grounded. The green LED is connected with pin 13 of Arduino board. Then we take servo motor and connect it with 5-volt pin and ground pin of Arduino, and its output is derived from digital pin 4. The servo motor that is connected with the Arduino is in turn directly tied with the knob of the gas regulator by a tensile thread, so as to acquire control over the supply of LP gas by rotating it. Let's try to understand the working procedure of our project by this data flow diagram. Firstly, we use a DC battery 9 to 12 volts and connect it with the Arduino board, and with the help of a jack to turn the system on. The green LED of the Arduino blinks, confirming the connection status is being established. Then after, the active mode of the gas sensor compels it to continuously monitor the surroundings, and we control its sensitivity. Then in normal situations, when LPG is proceeding through proper encased pipelines and there is no leakage, the status of the display which is connected to the Wi-Fi module follows statement gas connection normal, as the green LED glows to provide the visual satisfaction to the user. But in case there is leakage, the gas sensor induces an emergency situation in IOT system exactly as being programmed by enabling the buzzer sound on, blinking the red LED, and the servo motor turns the knob of the gas regulator to off state to terminate the gas supply and avoid any distress condition. The display which is being connected with the Wi-Fi module follows the statement as leakage at plug 1 detected. Let's try to make it clear through this video. Yeah, so this video helps us to understand the working procedure of this module accurately, and as you have seen, let's try to figure out the results what we depicted. The testing of the proposed system was carried out using a lighter as a replicate of LPG gas source, and we found that sensing time was immediate. And here, as you can see, figure 1.1 is the output of the normal gas connectivity, and similarly figure 2.1 represents the critical conditions of the gas leakage, whose amendment is swiftly carried out by servo motor by shifting the gas valve to off state and turning the buzzer and red LED on. Let's try to conclude. The first point is its low cost, that's around 400 rupees. Since the easy availability of this handy system can spread out and reach in every household who seek use of LPG for cooking and other purposes due to its cheap cost and easy installation. Since India is world's second largest LPG consumer after China, and nearly 80% of its population now have access to the LPG connectivity due to different government schemes available. And here I offer the solution through this simplified and reliable project. The second point is displaying gas outflow status. Since we are able to display the status on the screen, that signifies whether the gas connectivity is in normal state or the gas is in the emergency situation. And the third one is the automation. We don't need any manual efforts as system inserts the automatic closure of the gas from its from source using servo motors while a leakage is detected, and also there is no swifting, no rotation in the servo motors in normal state, in normal conditions. And some future recommendations are, since it's an established fact that research is a never-ending process and always it is a new beginning, but here are some suggestions, like it can be updated to monitor the level of gas left in the tank, and also it can be updated to transmit SMS alert to the concerned person. So this was our project, and for what we've worked, and hope you will like it. Thank you very much.